Okay, so we are in Statistical Rethinking, second edition, and we're just starting chapter 12. So we're in the easy questions here. So we'll look at 12E1 and 12E2. Okay, so first 12E1. Okay, so what is the difference between an ordered categorical variable and an unordered categorical variable? Okay, define and give an example of each. Okay, so let's just discuss these a little bit. So both ordered and unordered categorical variables or models, they have as their outcome categories rather than some quantity. Okay, so for instance, an ordered categorical variable or model might have as the outcome small, medium, and large. Okay, maybe these are shirt sizes or something like that. Okay, but an unordered categorical variable, okay, will have as, or model will have as the outcome something like red, blue, yellow, right? Where there are distinct categories, okay? But the difference though between the ordered small, medium, large and unordered red, blue, yellow is that there is actually some kind of, hierarchy or structure or ordering to the ordered categorical variable, okay? Medium really is bigger than smaller and large is bigger than medium. But there's no sense in which blue is bigger than red or red is bigger than blue or yellow is, bigger than, blue and red or whatever. Okay, so that's the difference then between these, all right? Now, it's worth bearing in mind a few things here, okay? One is that sometimes these different categories, these levels of a variable, they get encoded as a number, right? So we might call red 1 and blue 2 and yellow 3, but those are just labels. We might as well call them red, blue, yellow. Okay, in that sense, when we call them 1, 2, and 3 or something, those are just labels, right? There's some important ways in which unordered and ordered categorical variables differ from numbers. Okay, so let's look at those. So with red, blue, yellow, it's really simple to see why these don't at all behave like numbers, right? For one, there's no so whereas numbers, when you go from 1 to 2 and 2 to 3, what you're saying is that the second one is bigger than the first one and the third one is bigger than the second one. And there's no sense in which that's true here, okay, for the unordered case. But for the ordered case, it is true that medium is bigger than small and large is bigger than medium, okay? But where these differ from numbers, okay, is that if we were looking at the integers 1, 2, 3, we would say that 2 is 1 bigger than 1 and 3 is 1 bigger than 2. And if I went up to 4, I would again use an interval of 1 and 1. There would be this constant interval then separating these numbers. They would be different by some constant function. Okay, but in the ordered categorical variable, there's no guarantee. Although this might be the case, but there's nothing to guarantee that the variable the category medium is some fixed interval bigger than small, and that fixed interval is the same as the interval between medium and large. So even though these are ordered, they aren't ordered in a way that is systematic, we might say. Okay, so okay, on to 12E2. What kind of link function does an ordered logistic regression employ, and how does it differ from an ordinary logit? Okay, so the link function that gets deployed here, I think typically, is the cumulative logit function, all right? And that looks, well, it looks like this, okay? Now, this is just the logit link function if we just have two categories, okay? But once we have more than two categories, right? Once we have several categories, then this begins to differ because the probability that y is less than or equal to
k now must account for several categories rather than just the one in the numerator. So anyway, I hope that answer suffices, and we'll see you in the next video.